So I think the problem with times is that you're around time all of the time, and I think that people have this sort of intuitive understanding of time and how it works and how clocks work because they've been used to telling the time for most of their lives. But when you have to develop a software that deals with time, well, there are all of these extra considerations that you don't necessarily have to deal with on a day-to-day basis, but in software, you have to take care of them. So I'm going to talk a little bit about the kinds of problems that you're going to experience when you're developing software that relies on time. So I'm going to start with a story. What happened was I was handed a bug, and what the test analyst had complained about is that a piece of data that they were entering didn't have any effect, but if they refreshed the screen, it was fine. Now, I delved into this and I couldn't reproduce it immediately. It was quite difficult to figure out what was going on. So I called up the test analyst and they were able to reproduce it for me. I watched them do it and I was very confused, but eventually I figured it out. And what the real problem was on this occasion was that the developer had used the clock on the client to use the start to take the start date of this particular record. It was a record that you entered the value and it was meant to apply straight away, but it actually had a start date on it, and it only applied once the start date had arrived. And in the case of this test analyst, they were fully remote and they never came into the office, which meant that they never got a time update from the time server, and they were 10 seconds in the future. So what it meant was when they sent their data to the back end wrote the record, and the record wasn't active yet for another 10 seconds, and then when they refreshed it, the record suddenly showed up magically. And so I think the moral of this story is that you can't trust the clock. So today what we're going to talk about is what can go wrong with times. We're going to talk about local times and the problems with those, UTC time, date and time with offsets, time zones and locales, birthdays, and how clocks differ. So local times are good because the users will understand those. And if you're looking in the database, you as a developer will understand the times as well. You won't have to mentally do a time conversion in your mind, which, I've been doing this for a long time and I still can't do that. I really struggle with it. But it captures the actual time that the user would see, and so that's handy in that way. But one of the problems is that local times lose information twice a year, depending on the region that you're in. I live in New Zealand, and twice a year, once in spring and once in autumn, we have daylight savings changes, and that can mean that you either have a part of the day that doesn't exist in local time and another part of the day that exists twice. So usually late at night or early in the morning, 2 a.m. is when ours happens. And what that can mean is that if you have like events happening regularly, it means that trying to discern when that event actually happened can be difficult at those times of day. In a multi-region system, your local time isn't enough information, and it can be confusing. So an event that's recorded in Australia and an event that's recorded in South Africa, well, those events will, if they're recorded in local time, that will mean a different thing depending on which place you're in. and if you have a multi-region system, that might be confusing for users about the actual time that an event occurred. Local times are actually pretty good at doing date-based arithmetic, and that's because you can add whole days to a local time without disturbing any problems. Most of the time, on that one day of the year, if you're at 2 a.m., 2:30, perhaps adding a day is not going to work there, because that time either won't exist or it won't be clear which of those times it is. But most of the time, if you're talking about just dates, then adding a date is safe in local time. UTC time is good because it can be converted to the correct time in any region, and if it's converted, then the user sees it in their own time, which it might be confusing or it might be really clear depending on the kind of event that you're talking about. It's not disturbed by daylight savings, which is one of the real advantages of using UTC time, but it might not be clear about when the event actually happened, and what or where it happened in local time. It's typically a poor choice for date manipulation, and that's partly because that daylight saving thing that I described earlier, the starts and ends of your days will perhaps move depending on the time of year it is, and on those couple of days a year, the day's not actually 24 hours long, so you can't use simple date arithmetic on those. It's typically a good choice for time manipulation. So if you're adding hours or minutes or seconds, then great. I think that works, and it's a good choice to do that in UTC time. So one other way of storing dates, which captures a lot of the good qualities of local time and the good qualities of UTC time, is a date and time with an offset. And what's great about this is that you can see it in the actual time that the event was recorded, and it's clear about what time that was. And you have enough information to convert it to your local time as well. Given you know your own locale. But it's still a poor choice for date arithmetic, and that's partly because it's not clear from looking at the date and time with offset which locale you're in. So if you add a day to your date and time with the offset, well, actually it might be at a time where the offset should have changed, and so that's means that it's not a great choice for adding to or subtracting from. And I want to make clear that the offset doesn't capture all of the information about the locale that you're in. It captures the offset at that day and time, so that for that reason it's a poor choice of data arithmetic. So a time zone is usually enough to indicate when a particular region's daylight savings will change. The typical offset for that region, but quite often you'll have to store that information separately from the actual date, and that's partly because there aren't that many time formats that encode this information. But I think that storing UTC time and the locale information is typically a robust answer. However, if you are working on a system that operates in different locales and you've got users in different locales, one problem that you can run into is that the text format of the date is different in those different locales. And if you're not careful, then dates can be misinterpreted. In particular, There's a notable difference between the American standard dates and quite a bit of the rest of the world, and that's that the dates and the months, the day of the month and the month of the year are transposed in the American formats. And if your setting is different from what the user expects, then the user can, in a fair portion of dates, can enter the incorrect order, and the system won't be able to automatically detect that. So right up till the 12th day of the month, if you transpose the day in the month, then actually, there's no way that the system can tell. So I think that a good choice is, where possible, you use a date format that can't be misinterpreted, and ISO 8601 is a good choice. It's a standard one. It's endorsed by the ISO standards body, and one other advantage of using that date format is that your dates can be sortable lexically, so you just have to have them in text and you can still sort them, which is really, really handy. So birthdays are different again, and they are a special case. And the reason that they're a special case is that by convention, they just have a date. They typically don't have a time, although I understand if you wanted to argue with me about that. I was born at a particular time of the day, but typically I don't really consider that. Instead, I just think about my birth date. And one thing to consider about birthdays is that it's the same no matter where you are, and that's sort of a confusing convention. And so I think if you're working on a multi-region system and you have to respect people's birthdays, then you have a real challenge there about how to do that consistently. Do you do it based on where they live or where they currently are, or just use UTC, or use a specific other date that's set in their preferences? Where were you born? And we use that to determine when your actual date of birthday is, and that might be in the middle of the night and where you're living at the moment. I think good luck, and I don't have a really good way of doing this, but I think that not storing an offset is a good start. Okay, the final problems that I'm going to talk about are that clocks differ, and that story that I told you at the start of this video is an illustration of that. Clocks can drift for a lot of different reasons, but notably hardware differences. I think that different configuration, if your different systems have a different time zone set for their system clock, well, that can mean that they report a different system time, and you can be hours out. But using UTC is usually a good choice, apart from the fact that the systems drift. If you have a way of connecting to a time server, that's a really good way of keeping your times aligned. But even still, they can sort of differ depending on the latency from the time server to the individual clock. And I'm going to include this for completeness, but not because I think that you'll have to deal with it, and that's relativity. So there are two reasons that your clock might get out of sync in relativity. There's the special relativity case, and that's if your clock is on an object that's moving really, really fast compared to some other clock. And the other one is if the amount of gravity that your clock is experiencing is different from another clock, then those two clocks will drift out of sync as well. And there are practical reasons why you would have to deal with this if you're working on satellites, although my understanding is that it's down to tens of microseconds per day that you need to deal with. So, not big numbers here, but they do drift, and you need to potentially take care of them if you're dealing with satellites, which I'm not suggesting that you are. So what to do with all of this this mess then? Well, I think don't trust the clock on the client. If there's anything you can do about centralizing decisions about when times occur, then that is your best option. If you're going to do date arithmetic, do it in local time. If you're going to do time arithmetic, do it in UTC. Store the locale if you have it available, and try to be consistent with birthdays. And then when a machine is interpreting a date, I think your best choice of format is ISO 8601. And finally, if you like this or it was helpful, please leave a comment. Talk to you next time.